What do different temperature magnitudes mean? Imagine a world where everything is moving at different speeds, from icy cold to blazing hot. That's what temperature really tells us, how fast particles like atoms and molecules are bouncing around inside a substance. When particles move slowly, the temperature is low. When they move quickly, the temperature is high. It's all about energy, tiny bits of energy that particles have on average. The coldest temperature possible is called absolute zero. This is 0 Kelvin, which is about minus 273.15 degrees Celsius. At this point, particles are almost completely still, with minimal thermal motion. It's a theoretical limit because particles can't have less energy than this. If they did, it would mean negative energy, which isn't possible in our universe. Temperature scales help us measure these energy levels. The Kelvin scale starts at absolute zero and goes up from there. Each step of 1 Kelvin is the same size as 1 degree Celsius, but they start at different points. Water freezes at 273.15 Kelvin and boils at 373.15 Kelvin. That makes Kelvin perfect for scientific work because it's based on absolute energy levels. The Celsius scale is more familiar in everyday life. It sets 0 degrees as the freezing point of water and 100 degrees as the boiling point, both at standard atmospheric pressure. Celsius is offset from Kelvin by 273.15 degrees, so you can convert easily by adding or subtracting that number. The Fahrenheit scale is mainly used in the United States. It sets water's freezing point at 32 degrees and boiling at 212 degrees. The difference in size between Fahrenheit degrees and Celsius degrees is larger, making Fahrenheit less precise for scientific purposes but still useful for weather reports. Understanding what different temperature magnitudes mean helps us see how substances behave. At very low temperatures near absolute zero, materials can become solids or show quantum effects like superconductivity. At moderate temperatures like room temperature, particles move more freely, and liquids and gases behave normally. When temperatures rise, particles gain more energy, and substances can turn into gases or plasmas or undergo chemical reactions. In thermodynamics, temperature is key because it drives heat flow. Heat always moves from higher to lower temperatures, and this flow influences how systems change. Temperature also relates directly to the internal energy of a system and affects properties like pressure and volume, especially in gases. By measuring temperature on scales like Kelvin, scientists can describe energy states precisely. This helps predict how systems respond to changes and understand the energy transformations that happen all around us. So, different temperature magnitudes tell us a lot about the microscopic world and how it shapes the physical world we see every day.